Hello everyone, welcome to Gate Pass. In this video, I am going to take problems that appeared in year 2013 and which were related to thermodynamics. So the first problem which I have selected is question number 31 of Gate paper 2013. In this they talk about a binary liquid mixture which is in equilibrium with its vapor at a temperature of 300 Kelvin. The mole fraction of component 1 in the liquid phase is given as 0.4 and the molar excess Gibbs free energy GE, so this is a mixture property, it is equal to 200 joules per mole. They have further given you that your ln gamma 1, your gamma 1 is your activity coefficient, so your ln gamma 1 is equal to 0.09 and you have to find out what is your ln gamma 2. So it's a very straightforward problem. What you have to realize is that your ln gamma I is a partial property with respect to your molar excess Gibbs free energy. When I say this, what do I mean? That your ln gamma I, that is equal to GE. So this is the relation you know from your solution thermodynamics. Okay. So they have not given me the partial molar excess Gibbs free energy of any of the component. What they have given me is the mixture property, that is GE. Okay. So first of all, I will write down the equation which relates the partial molar properties to the mixture property. And what is that? We have seen it several times. That is your summability rule. So for any property M, I can write my summability relation as, that is the mixture property, that is equal to summation over all I xi mi bar, which is where the m bar I, that is the partial molar property of component I. Okay. So if I apply that summability relation, okay, then I can write that your GE by RT, that is equal to x1 G1 bar E by RT plus x2 G2 bar E by RT. Okay. That is how I can write. But I know that this thing is equal to ln gamma 1 and this thing is equal to ln gamma 2. So I can write that x1 ln gamma 1 plus x2 ln gamma 2, that is equal to my excess Gibbs free energy divided by RT. Fine. So what I have done, first of all, I have written the relation between the partial molar excess Gibbs free energy and ln gamma I, and then I applied the summability rule, put this over here and then got the relation. Now everything else is very simple because I have to find out ln gamma 2 in this equation and everything else I know. So I will quickly put everything there. So your GE is 200, R is 8.314, temperature is already given in Kelvin, so I don't have to bother about it. X1 is 0.4, so 0.4. ln gamma 1 is given as 0.09, so multiply it with 0.09 plus what is x2? 1 minus x1, that is 0.6 ln gamma 2. This is a very simple equation. So you get the value of ln gamma 2 as 0.073. They have asked you to report up to 2 decimal places, then you can report it as 0.07. Okay. So this is your answer. So the next problem which I am taking is question number 7. It talks about the equation of state which is explicit in P and cubic in specific volume V. So I have written down the form of equation, that is the generic cubic equation of state. It is explicit in P and cubic in volume V. Okay. At critical point C, an isotherm which is passing through this critical point C, now they have asked you what does it satisfy. Okay. So for you I have drawn on PV curve an isotherm which is passing through a critical point C. So what you observe is that you observe an inflection at this point C where your first derivative and your second derivative are 0. Okay. So straight away your option D is correct. So next question which I am going to take is question number 5. It talks about a gas phase reaction between hydrogen and iodine and hydrogen iodide. Okay, so this is the reversible reaction which they had given. It is taking place in a gas phase, and they have asked you at equilibrium what are the number of thermodynamic degrees of freedom. So we all know the definition of degree of freedom, that is F. It is given as C minus P plus 2 minus R minus S. Okay. Now let's go through this. F is degree of freedom. C is the number of components. How many number of components do you have? HI is 1, H2 is second, I2 is third. So you have 3 components. How many phases do you have? So it's a gas phase reaction, so there is only one phase. Okay, how many reactions are there? Only one. S is some special constraints. Are there any special constraints given over here? No, so that is 0. Okay, so then your degree of freedom is 3 minus 1 is 2, 2 plus 2, 4, 4 minus 1 is 3. So your degree of freedom is 3. Okay, very simple, straightforward problem. Okay, question number 6. It talks about a closed system and which contains a pure fluid. Now the thermodynamic state of this system, it changes from T1 P1 to T2 P2, where we are denoting that the heat absorbed by the system is positive and the work done by the system is positive. Okay, so in this notation, let's write down your first law. So your first law will be the change in internal energy, that is equal to Q minus W. Okay, so keep this in mind. They have given you the sign convention which was followed in olden days. Okay, that your change in the internal energy, that is equal to Q minus W, where Q is the heat absorbed by the system and W is the work done by the system. Okay, so they have defined the sign convention. Now they have asked which of them is correct. Okay, so Q is path independent, W is path dependent. No, we know that both these quantities are path functions, so option A is wrong. Q is path dependent, W is path independent. Of course, this is also wrong because both of them are path functions. Q minus W is path independent. Okay, for the given sign convention, that's for PC, Q minus W is equal to your change in internal energy. Internal energy is a state function, so it should be path independent. So basically your Q minus W is path independent. Q plus W is path independent? No, for the given sign convention, this is a wrong option. Okay,